Hello, this is University of Augsburg, and I'm going to give you a quick overlook of the work we are doing within the present project. First off, at University of Augsburg, we're dealing with human-computer interaction, which happens whenever human and machine join in a collaborative tasks. We use artificial intelligence and machine learning to develop systems that are able to recognize user states and emotions. These can then be used to enable a natural and believable reaction of your system and your present agent. So, we focus on the user. The user emits social signals via facial expressions, with his voice, with his body language, and even with his physiological signals. We collect and we process and we interpret these natural human signals to recognize affective states. And this is done by capturing the human signals with the respective sensory hardware, like for example webcams, microphones, or even sensors attached to your body. This is what the real-time processing of these sensor signals looks like. I have put here some examples and some configurable pipeline, which consists of some of these components, is running in the background of the present application and capturing the user signals and interpreting them. It interprets these signals in a way that we get the current emotional state of the user. So his social signals are mapped to an emotional state, and with this emotional state we can calculate an emotion for the agent. This is not only based on the emotion he's currently seeing in the user, it's also based on his personality and all kinds of feedback he's getting from the application. Furthermore, we can use these social signals to have in the background a socially aware reinforcement algorithm running, which is taking the positive or negative reactions of the user as input and as a feedback mechanism to over time adapt the behavior of the physical agent to the likings of the user. Let's go a bit more into detail. So what we can show with the agent are emotions in general, which we can vary based on the intensity of the emotions that are shown. And with the reinforcement learning algorithm, we can adapt the intensity that is shown to the likings of the user. Also, the agent is able to give back channel and feedback to the user, like for example with the speech, he is talking to the user, or the non-verbal back channel behavior, like for example nodding or head shakes, that are given back to the user, and we can vary these in style, also based on the liking of the user. So we have an adaptation of the back channel behavior and the emotions based on the feedback, on the implicit feedback we receive from the user via his emotions. So what is the ultimate goal? The ultimate goal is a potential effective loop between the user and the agent. So on the one hand, we look at the user, we recognize his affective states. This also gives an implicit feedback to the agent, which uses this feedback to adapt his synthesized affective states and to model the effective responses he gives back to the user. And if we achieve a reaction in the user based on this adapted behavior, we get this effective loop in which the actions and reactions of the user and the agent bounce off of each other, and they react and interact in a very natural way. Within the present project, the professional recordings and the high quality of the model design enables us to hopefully maximize this effective impact. And here you see a little demo in which the reactions and the emotions of the user are measured in real time, and the agent is having his own personality and his own emotions and is playing off of the input he receives from the user.